Good morning, everyone. Thank you for joining us. Welcome back. We're glad that you're here. I'm Steve.
And I'm Scott.
Together, we're Backyard Musing Science and Technology Channel.
Yep, and we are talking about one of our combined more favorite subjects. I mean, Steve is into the quantum and the nano and computing and all that stuff, but space is our combined, I think, best topic, and we're talking about it today. So here we go. A lot have been happening lately in space. So
we might as well mention that Artemis 2 is well on its way to shoot around the moon. That's very exciting.
Yeah, I think it's going to circle the moon, what, 2 or 3 times, I think, and then come back? Is it a couple times, or?
I don't know. I would think if you're there, you might as well orbit a couple times and then come back.
Yeah, and I think I mentioned the other day that it was like 250,000 mile mission, but I read the other day an updated article that it's like 487,000 by the time they're counting everything down. I mean, the whole route. So it's a pretty long mission. So very cool.
Okay. A massive crater on asteroid Psyche may hold the key to whether it's a lost planet's core or something more complex. So this asteroid is. Remember, we did a story on Theia, which is thought to be the core of Earth. It crashed into proto-Earth and made the Earth that we have today. This could be the same thing. New simulations suggest NASA's upcoming mission could finally solve the mystery. More than 200 years after asteroid 16 Psyche was first identified, scientists are still trying to understand how it formed. Would you like to know more?
Psyche is the 10th most massive object in the main asteroid belt between Mars and Jupiter, and the largest known metal-rich asteroid, measuring about 145 or 140 miles across. NASA's Psyche mission is set to arrive in 2029, so just a couple of years from now, to investigate its origin. Researchers think it could be a remnant of an early planet that was torn apart by massive impacts, or a fragment of a once layered body that lost its rocky outer layer. Okay.
Other theories suggest Psyche may have started out rich in metal or became a mixture of rock and metal after repeated collisions with other asteroids. Each possibility points to a different explanation for how planets form in the early solar system.
Okay, to explore these ideas, scientists at the University of Arizona's Lunar and Planetary Laboratory ran simulations to study how a large crater near Psyche's North Pole may have formed under different scenarios. Their study, published in JGR Planets, provides predictions that will help researchers interpret data from NASA's Psyche mission once it arrives. When combined with spacecraft observations, these results could finally reveal what Psyche is made of. Okay.
Quote, large impact basins or craters excavate deep into the asteroid, which gives clues about what its interior is made of, said Namya Baijal, a doctoral candidate at the LPL and first author of the paper. Continuing his or her quote, can't tell, probably a her, by simulating the formation of one of its largest craters, we were able to make testable predictions for Psyche's overall composition when the spacecraft arrives.
Less than 10% of asteroids in the main belt are metal-rich, and Psyche is the largest of them. Still, scientists will need direct measurements from the spacecraft to determine how metal is arranged inside. Interesting.
If an asteroid contains a lot of empty space, it can compress more easily during an impact. This allows it to absorb energy more efficiently, producing deeper and steeper craters with less debris spread across the surface. By comparing these simulated features with real observations, scientists can test whether Psyche has a layered structure of metal and rock or more mixed composition.
So are we saying here that the moon is probably not made out of green cheese?
Right, there's no man there either.
Okay, all right. If Psyche turns out to be an exposed planetary core, stripped of most of its outer layers, it could provide a rare look at a violent phase of planet formation that scientists cannot directly observe. Using detailed shape models based on telescope data, the researchers built a 3D version of Psyche and recreated the formation of a large crater about 30 miles wide and 3 miles deep. In the simulations, the asteroid, you think it's made out of green cheese? I do too.
Baba thinks it does. It is.
Yeah, that's what I thought. The team tested different impactor sizes and compared two possible internal structures, metallic core and mixed rock and metal, to see which best matched the observed crater.
Unlike planets, many asteroids are not solid rock. They often contain fractured material and empty spaces from past collisions. By including porosity in their models, the researchers showed that it strongly influences both crater shape and how material is ejected during impacts.
The Psyche spacecraft is equipped to study the asteroid's surface, gravity, magnetic field, and composition. Along with crater shapes, these simulations predict other features scientists can look for, such as charges in density caused by impacts compressing the interior and the distribution of metal-rich debris across the surface. You caught me off guard there with that slide. That's very cool.
Yeah, so that's what the spacecraft's going to look like when it comes up on Psyche.
Yeah, and that's a very interesting. This is an asteroid.
Asteroid. 140 miles wide.
Yeah.
So that could be like the core of a proto-Earth or a very small core, because 140 miles is not much compared to our Earth.
Yeah. Could do some damage, though.
Yeah, or help form a planet, you know?
Yeah. Yeah, and that's very cool. And those craters, just how those craters are.
It's like on the moon.
Yeah, and the ridges across that, right across the top there. That's very cool.
Yeah.
Very cool. So,
all right, folks, thanks for joining us. We'll catch you in the afternoon.
Catch you on the second one this afternoon. Take care.